Okay, so welcome everyone. So as for I was discussing that in this lecture series where I'm uploading different videos on the special topics in organic chemistry, such as different name reactions, different reaction mechanisms, important reactions. Okay, so today the which and those reactions of inorganic chemistry which is the top topic of your boards in JEE and the NEET course curriculum. So today the reaction which I picked up is a very important reaction of the phenols or aromatic alcohols. And this reaction is known as, you know this, it's known as Riemer Tiemann reaction. REI, Riemer Tiemann reaction. Okay, Riemer Tiemann reaction. Now, this Riemer Tiemann reaction is important and you use this method to synthesize phenolic aldehyde. That means this phenol, let's say you have a phenol, okay, easily available phenol, and you convert this phenol to phenolic aldehyde, to convert to phenolic aldehyde. Okay. Now, what you require for this reaction? What reagents you require? You require CHCl3, which is chloroform, and you require OH minus, a base. Basically, in chloroform base, you treat with phenol and you get this phenolic aldehyde. This is phenolic, or I would make the name. This is orthohydroxybenzaldehyde, or we know a very beautiful name of this molecule. This is known as salicylic. Okay, salicylic. Now, this reaction, you see, you remember this reaction, this particular reagent. Remember, when I was discussing that that is one of the important reaction, which is okay. So this particular reagent, hmm, this particular reagent is a one type of special combination. If you see anywhere, if you let's say you are figuring it out, if you're figuring it out any reaction, your unknown reaction you got, okay, and in that unknown reaction, if you see this kind of combination, chloroform with in presence of base, those kind of reactions will undergo via carbene mechanisms. Okay, so let's revise again the carbene reaction. So what happens? You have CH. Let me write like this: CH, Cl, Cl, Cl. This is the structure of the chloroform. So in presence of a base, what it will do? So this is an acidic hydrogen because why? There is a three chloride group, chlorine group attached with the carbon. So this is definitely the acidic hydrogen. It will get abstracted. So what will happen? It will form C minus Cl, Cl, Cl plus water. Now this CCl3 molecule will undergo an alpha elimination reaction minus Cl minus. Okay, alpha elimination reaction, the chloride will be liberated. So this carbon CCl2 will be a carbene. It is known as the dichlorocarbene, and this is a very stable carbene. Now this carbene, as we know from our knowledge, the carbene is an electron deficient species. Okay, carbene is an electron deficient species and it forms via alpha elimination reaction. Okay, now this alpha elimination reaction forms this carbene. Now this carbene will do its part now. What it will do? Since it's an electron deficient species, the benzene ring, the phenolic ring here, OH, in presence of base, what is happened here? In presence of base, this already in phenoxide ion state. Already is in phenoxide ion state. So what will happen? This CCl2 carbene, now this phenoxide ion will attack the CCl2, and it will go. This is, let me write it here. This is step 1 and this is step 2. Okay. Now this will attack. So next what is happening here? So this is double bonded O and one hydrogen here and CCl2 minus, correct? CCl2 minus. Now this CCl2 minus, what it will happen? Now this is also, and this is also basic, and so it will abstract the hydrogen. The bond will come back and it will release the oxygen. So what is the here? What you are getting the product? So this is CHCl2 CHCl2 O minus. Okay, CHCl2 O minus. Okay, so now it's done. So this is fine. Now this, in presence of basic environment, this particular molecule will undergo a rearrangement. Now let's look at that what kind of rearrangement this molecule will undergo. Now let's rub this part, first part. Okay. So what we have here, here we have O minus, okay, and ClH, correct? Okay. Now in presence of base, what will happen here? This OH minus here, sorry, the OH minus here now will behave as a nucleophile. So what will happen? It will attack here, this center, and release the chlorine. So what will happen next step? It is O minus COH ClH. Next step, there will be a elimination. So this will come here and the chlorine will eliminate. So okay. So next step, O minus C double bonded OH. Now next one, with presence of, if you do a hydrolysis workup, acid hydrolysis, what you will end up with? You will end up with a phenolic aldehyde. You will end up with a phenolic aldehyde, orthohydroxy benzaldehyde. Okay. So this is now this one. Now this way, this reaction, this Tiemann reaction proceeds. Now the next question is, what is so important of this product? Why this reaction is so much important? Let us look at this. Why this reaction is so much important? This important, that's why this reaction means was that time was means when this reaction came out, it was made that it took a huge revolution in your medicinal field particularly. Now I will tell you how. Okay, let's say this particularly this phenolic aldehyde. Okay, this phenolic aldehyde, this method if people uses, and sometimes this phenolic aldehyde from the phenol, you can easily make different kinds of medicines also. Okay, what kind of medicines you can make from this phenol? Okay, by this phenol you can make aspirins also, you can make, and you can also make the, what is it called, oil of wintergreen, which is known as methyl salicylate. Okay, which is the methox let me draw that first one. Okay, so what is the first? You have this phenol. Okay, you have this phenol. Now this phenol, instead of treating with like the same way, the method, the Riemer Tiemann method is what you treat chloroform in presence of base, right? So what I will do here, instead of giving a chloroform, which is chloroform is the first with the moiety for the formation of the aldehyde, instead of giving chloroform, the same technique what I will use for the, I will give, instead of chloroform, I will give carbon dioxide here. The first step, if I give carbon dioxide in presence of base, And number two, if I do an hydrolysis, if I do an acid hydrolysis in carbon dioxide in presence of base hydrolysis, what I will end up with? I will end up with OH, COOH. This is known as salicylic acid. Salicylic acid or orthohydroxybenzoic acid. Orthohydroxybenzoic acid. Okay. Now the idea was like this. In case of Riemer Tiemann reaction, what you did, you took chloroform in presence of base and you put an aldehyde here. Now, if I took in presence of chloroform, instead of chloroform, if I take a carbon dioxide, I will put a COOH group here. Correct? Then an acid group here. Now, this acid group in presence of AC2O, acetic anhydride. What is the structure of acetic anhydride? Let's look at C. Now, this is your acetic anhydride. Okay. Now, in presence of acidic anhydride, what will happen? This O has a lone pair of electrons. It will attack this position and come out and take away again. Okay. So, what you will put making here? You are basically here making C, sorry, O, C double bonded O. Okay. O, CO, CH3, C double OH. CO, CH3. CO, CH3. Acha. Now, this is known as acetyl salicylic acid. This is known as acetyl salicylic acid. And this is a very important compound. And this compound, what we know as a name of aspirin. Aspirin is a very medicine of your headache. Aspirin. Okay. Acetyl salicylic acid. Next one, another application. Another application is you have this salicylic acid, let's say OH, COOH. You have this salicylic acid. Okay. Now, if you treat this salicylic acid with, if you treat this salicylic acid with methanol in presence of sulfuric acid, if you treat with this methanol in presence of sulfuric acid, H2SO4, what will happen? Definitely, you have a acid here and you have an alcohol here. So what will happen? It will form a ester, right? Okay, this is known as very good name methyl salicylate. Or we know it's in another name. It is called oil of wintergreen. Oil of wintergreen. Okay, so these two are the applications of the phenolic compounds, and this idea of the formation of this acetyl salicylic acid or the aspirin was came from the idea of this Riemer Tiemann reaction, and this makes this Riemer Tiemann reaction so much important. Okay, so this all from the mechanism of the Riemer Tiemann reaction and the two applications and of the derivative of the phenolic compounds. Okay, so if you like this video, please hit the like button and subscribe the channel to get much more updates on the different organic chemistry topics on the of the boards in for your boards GE and the NEET. And I am okay. And if you have any doubts and queries, please feel free to write in the comment section. Okay.